and welcome to my maths class. Today we're going to do general solution. Now general solution means calculating an angle, which means you have to be familiar with the work in grade 10. Go over the summary we had done over all grade 10 work before continuing with the section. Now when we are doing general solution, so it could be a basic question like sin theta is equal to, in grade 10 you learned how to press shift, sin and then the value, giving us theta is equal to 45 degrees. But now in grade 11 it gets a bit more challenging. The first rule says get the ratio alone. When we're talking of getting the ratio alone, you must remember it does not refer to the thing immediately next to the ratio. Now look at the difference. If I give you 2 sin theta is equal to 1, you have to get rid of the 2. So you end up with sin theta is equal to 1 over 2. But if I give you sin 2 theta is equal to 1, then you can't remove the 2. Can you see the difference? Right, now this is what you must remember. Anything immediately next to the ratio. So if you have your ratio and anything immediately to the right of your ratio, that is basically one term to your ratio, cannot move. Anything immediately to your ratio cannot move. But anything that is further away from your ratio must move. So if I give you a 2 and then your ratio and then your 2 theta plus maybe a 4. So the things that would move is the 2 and the 4. But the 2 that's next to the ratio doesn't move. So number one, when we say get your ratio alone, you must be careful that we are not talking of the value that is immediately attached to your ratio on the right hand side. Right. So our first rule is to get the ratio alone. The second rule is to use your calculator. Now, at this step you must be careful. When I say use your calculator, you must remember in your calculator, don't put a negative. Number 3, you're going to do your normal restriction. The same way you had gotten your restriction when you were doing Pythagoras, when you were doing special angles, when you were doing reduction. You would use the exact same method to get your restriction. Okay, number 4, you're going to go to your t. But your t is based on your reduction. It's exactly the same as your previous reduction, but more specifically your 180 and your 360. I had mentioned before that 90 and 270 are very rarely used. The heart of it is 180 and 360. Now let us do an example. If I gave you 10 theta is equal to root of 3. Now get the ratio alone. This is a basic one. So we already have our ratio alone. You press it into your calculator. So you're going to press shift 10 root of 3, which is again your grade 10 work. We have that theta is 60 degrees. Now from this level we're going to start doing new work. We're going to look at our restriction. They give us that 10 is positive. Because 10 is positive, I know it's in my first and my third quadrant. They didn't give me another restriction, maybe limiting me between 0 and 360 or 0 and 720. When there is no restriction given or no second restriction given, then I simply accept it as from 0 to 360. Now, which quadrants am I working in? So when we looked, because 10 was positive, we're working in the first and the third quadrant. Now let's do our T. First and third. Now the first quadrant is exactly as the calculator. So the little block is emphasizing what is the calculator. So we're going to have theta is equal to 60 degrees. And in the third one, we're going to have theta is equal to 180 plus 60 degrees. So our final answer here is theta is equal to 240 degrees, and for number 1, theta is equal to 60 degrees. But there is one more step. In grade 10, you had learned in the graphs that the period of a 10 graph is plus 180 degrees. So the period keeps on repeating itself. The graph keeps on repeating itself after 180 degrees. So our final general solution is theta is going to equal to 60 plus k 180. And here theta is equal to 240 plus k 180. Now where am I getting the 180s? Is because I know the periods of the graph. The period of a 10 graph is plus k 180. This would have been a basic of grade 10. The only difference would be when I start putting it into the quadrant. But what I want to emphasize on now is the negative, and then how do we use our restrictions more, and how do we use our general solution, in other words the plus k's. Right, thank you for watching.